So, you write a piece of C code, you hit compile, and you figure the compiler gets to work right away. But what if I told you there's a secret first step, a kind of unseen preparation that happens before the compiler ever lays eyes on your code? Today, we're going to pull back that curtain and see what's really going on backstage.
So let me just ask you straight up. What really happens in that moment between you saving your file and the compiler actually starting its job? It's a step that, honestly, a lot of programmers kind of gloss over, but getting a handle on it can completely change the way you write your code. And the answer is the C preprocessor. The best way to think about it is like a stage manager at a theater. You know, the compiler is the big shot director who runs the show, but the preprocessor is the one working behind the scenes, getting all the scripts in order, setting up the props, and making sure everything's ready to go.
Okay, so what is this thing technically? Well, it's a program all on its own. Its only job is to scan your code looking for special commands. And you can spot them a mile away. Every single one starts with that hash symbol, or the pound sign. That little hashtag is the preprocessor's signal to wake up and get to work.
So what does our stage manager actually do? Well, it pretty much has a playbook with three main jobs that are absolutely fundamental to how C programs get built. These three jobs are 1. File inclusion, which is like gathering up all the different pages of the script. 2. Macro definition, which is like creating shortcuts or nicknames for things. And 3. Conditional compilation, which is like deciding which scenes are going to be in tonight's performance. So let's break these down one by one. First up, let's talk about including external code. See, your program almost never lives in a little bubble all by itself. It needs other tools, it needs libraries, it needs other pieces of code to work. And the preprocessor is the one that brings it all together. And the command for this, #include, is actually beautifully simple. It's a direct order. It tells the preprocessor, hey, go find this file and I want you to literally copy and paste everything inside of it right here into my code. That's it. It's how you get access to powerful functions like printf from the standard library. Now, you've probably noticed there are two ways to do this. When you use these angle brackets, like with stadio.h, you're telling the preprocessor to look in the standard system folders where all the official libraries live. But when you use double quotes, you're telling it, hey, look in my current project folder first. So it's a simple rule of thumb. Angle brackets for system stuff, quotes for your own stuff. All right, on to the second job, defining constants, or as they're more broadly known, macros. This is where the preprocessor really helps you make your code cleaner, way more readable, and a whole lot easier to update down the line. Here's the define directive in its most basic form. What we're doing here is telling the preprocessor, hey, from now on, anytime you see the letter A in this file, I want you to just replace it with the number 10. It's kind of like giving a nickname to a value. And this is a really critical point. This is not a variable. The preprocessor is just doing the simple brute force text replacement. It goes through your file, finds every single A, and swaps it for a 10. The compiler never even knows A existed. It only ever sees the number 10. This is amazing for things like a tax rate or a maximum array size that you use all over your program. Okay, now for what is arguably the most powerful job of them all, conditional compilation. This lets our stage manager decide which parts of the script, which lines of your code, even get handed to the director in the first place. It lets you build incredibly flexible and adaptable programs. The most basic checks are #if, then #if not. #if A is just asking the question, hey, has the constant A been defined somewhere before this line? If the answer is yes, then the code that follows gets included. And you guessed it, #if not A does the exact opposite. It's asking, has A not been defined? This is super common in header files to make sure you don't accidentally include them more than once. And hey, just as you can define something, you can also, well, undefine it. The #undef command basically tells the preprocessor, you know that definition you learned earlier? Forget about it. This gives you some really fine-grained control over which code blocks are active where.
Let's look at this in action. Remember we defined A as 10? So the preprocessor sees this line, #A greater than 5. It asks, is 10 greater than 5? Yep, it sure is. So it keeps that first printf statement. And the code in the #else block? Poof! It's just gone. The compiler will never even know it was there.
And you can build even more complex logic with a full if-else-if ladder. The preprocessor just goes down the list. It checks the first condition, #A greater than 5. Since that's true, it keeps that line and just ignores everything else. But if A was, say, 3, it would skip that,
go to the hashtag elif, which is just short for else if, and check that condition. And if nothing matched, it would fall back to the final hashtag else.
So we've seen the three big jobs, including files, defining macros, and using conditions. But why? Why is this unseen first step so important for writing really good code?
You know, when you get right down to it, the preprocessor gives you superpowers. Hashtag include keeps your code neat and organized. Hashtag define means you can update one value in one place and have it safely change everywhere, which prevents a ton of bugs. And conditional compilation? That's the pro's secret weapon. It lets you write code that can adapt to different operating systems or even turn features on and off, like creating a special debug version of your app that has extra logging that gets totally stripped out of the final version you send to users.
So you see, the C preprocessor isn't just some weird quirk. It's a fundamental tool for writing code that's efficient, easy to maintain, and can run anywhere. By understanding these pre-rules, you get a whole new level of control. So the real question is, now that you know how the Backstage Manager works, how are you going to use it to make your next program a masterpiece?